Hello and welcome, my dear students, to the last part for grade 11 elite on module 1 vectors. In today's session, we are going to cover end of term exam questions, selected solutions for the important questions from module of vectors. So stay glued to me, with me to the session. It's going to be a long video, but I'm going to select some questions which I'm going to be explaining you in detail from the lesson of vectors. Hello and welcome, my dear students, to today's session on vectors. Let's start with module 1, vectors. Okay, this is the first question. I will not be able to solve this question completely for you, but I can give you a hint because this question requires ruler and compass. So you need ruler to measure the length of these vectors. So A vector is given, B vector is given, like that, C, D, M, N, and so many vectors. So you need the measurement of exact length using the ruler and do that measurement in centimeters, because here it is asking you the answer in centimeter. And then for the direction, for the angle, you need the compass. So please use that. I will not be able to show that digitally here, so that's the reason why I can't show you the answer. But yes, I have provided the final answers in pink here, and I will give you a hint that will be very useful for solving these questions. The hint is the two methods that will help you. Either you use the triangle method, which is called tip to tail method, or you use the other one is called parallelogram method, which is called tail to tail method. In these two methods, basically the important point is that the resultant is the vector from the tail of A to the tip of the B vector. This is for triangle method. For parallelogram method, you use tail to tail method, which is resultant is the vector that forms the diagonal of the vector. So if you have the diagonal of the vector, that is going to give you the diagonal of the parallelogram. So if you have the parallelogram side represented by vector A and B, then the diagonal will give you the resultant. So use that to get your answer. Okay, so let's draw the vector diagram for question 36 and then solve it. So I hope you know this is north, this is south, this is west direction. So what is happening? Lamis is leaving her house and drives north on this street for 2.4 kilometers. So from this point, if she is starting from the origin, she is going 2.4 kilometers. So I'm just roughly drawing. This is, she's going in the north direction. This is the arrow pointing towards north, and she's covering 2.4 kilometers. Now she turns left on the Freedom Street, so she's going in this direction now, and she's covering more, little bit more than this. She's covering 3.1 kilometers, and then she turns right. Right means in this direction on Hope Street for another 5.8 kilometers. So you have to express Lami's commute as a linear combination of vectors I and j. So I hope you know I is the unit vector along the x-axis, j is the unit vector along the y-axis. So if you look carefully, this is the point from where we begin. This is the x-axis, this is the y-axis. Okay, so you begin with origin. So this is 2.5 kilometers in the y direction, that means in the j direction. Similarly, this is also parallel to y axis, so in the j direction. This is parallel to the x axis, so this is the I direction. Do you understand this? See what I'm trying to do. I'm trying to identify I and j vectors. Which one is which? So this one is on the y-axis, so it is definitely going to give you value towards j. This one is parallel to y-axis, so it is going to add up for the y value. So 5.8 and 2.4 will be added. These two vectors will contribute to the j vector, and this one will contribute to the k vector. Now because the direction is left, it is parallel to the negative side of the x-axis, so it will be having the direction negative 3.1 kilometers. So let's write now. So Lami's commute, let us say it is vector AB. It is equal to, for x it is minus 3.1 I, plus for j it is these two added, so 2.4 plus 5.8 j, that is equal to negative 3.1 I plus 8.2 j. This is how you solve using the vector knowledge and vector diagram and the linear combination of vectors I and j. Similarly, you solve question 37. So for question 55, 56 and 57 that you will be just be solving in the next slide, you will see that the magnitude and direction are not same for both the vectors, hence they are not equivalent. For question 56, the direction of the two vectors is same, but the magnitude is different, so they are not equivalent. However, for question 57, the answer is yes, that both the magnitude and the direction of both the vectors is same, so they are equivalent. Determine whether AB and CD with the initial and terminal points given are equivalent. So it will be equivalent if the magnitude is also equal and if the direction is also same. If so, prove that AB is equal to CD. If not, explain why not. So let's do the first part, answer 55. So first we calculate the magnitude of AB vector, which is equal to x2 minus x1, y2 minus y1. So this is equal to A is given, B is given. So it will be 6 minus 3 comma 9 minus 5, which is equal to 3 comma 2. Similarly, so the magnitude of AB would be 3 square plus 4 square, which is 9 plus 16, which is square root of 25, which is 5 units. Okay, now let's calculate the angle. So tan of theta is equal to 4 divided by 3, or theta is equal to tan inverse 4 by 3. This is the angle that you have got here. This is the magnitude. We are solving question 55. So let's calculate CD also. I'm going to change the color for CD. So for CD, you are going to use the same formula, x2 minus x1 plus y2 minus y1. So this comes out to be 2 comma 4. Now calculate magnitude of CD. Magnitude of CD is going to be the square root of 2 square plus 4 square, which is equal to 4 plus 16, which is equal to square root of 19. So if you see, the magnitude is different, so they cannot be equivalent. Even the direction tan of theta would be equal to y by x. So it will be 4 by 2, which is 1 by 2. So theta is equal to tan inverse 1 by 2. So the magnitude is also different, the angle is also different. So they cannot be equivalent. Therefore, the answer is no. Because what is the reason? Magnitude and direction both are different. So they cannot be equivalent or equal vectors. Let's solve question 56 and 57 also in the next slide. Okay, let's solve 56 here. So in 56, we first calculate the magnitude of AB. So AB is equal to minus 8 plus 4, comma 1 plus 5, using x2 minus x1, y2 minus y1, so minus 4, comma 6, or absolute value of AB is minus 4 square plus 6 square, which is coming out to be 16 plus 36, or square root of 52. Let's calculate direction. So tan theta is 6 over 4. Oh, 6 over minus 4. So this is 3 comma minus 2. So theta is tan inverse 3 comma minus 2. This is the direction. Magnitude we have already got. Let's now calculate for the next vector CD. So for CD it is square root of 1 minus 3 whole square plus 0 plus 3 whole square. So this is equal to minus 2 whole square plus 3 square, or square root of 4 plus 9, which is square root of 13. Now let's calculate angle. Tan theta is equal to 3 over minus 2, or theta is equal to tan inverse 3 over minus 2. So if you notice here the angle is same, but the magnitude is different. Here it is square root 52, here it is 19. So the answer will be no, they are not equivalent, because in order to be equivalent, both the magnitude and direction has to be equal, and that is what is going to happen in question 57. Let's calculate answers to 57. So first we calculate AB vector. So AB vector is x2 minus x1 comma y2 minus y1, which is equal to minus 10, sorry, which is equal to 0 minus 1 comma minus 10 minus of minus 3. So this is going to be minus 1 comma minus 10 plus 3, or minus 1 comma minus 7. Now if you calculate the absolute value, it will be equal to the magnitude of minus 1 square plus minus 7 square, which is equal to 1 plus 49, or square root of 50. Now we want to calculate the angle. So tan of theta will be equal to minus 7 over minus 1, or 7 over 1. So theta is tan inverse 7. Now let's calculate for CD. For CD it is equal to 10 minus 11 comma 1 minus 8, which is equal to minus 1 comma minus 7. So the absolute value is going to be minus 1 square plus minus 7 square, which is same as square root of 50. Also the angle tan theta would be equal to minus 7 over minus 1, or 7. So theta is going to be tan inverse of 7. Now if you see carefully, both the magnitude and the direction are same. So answer is yes, they are equivalent vectors. So the condition, both magnitude and direction, has been justified. So for the question number 59, the answers are given to here, given to you here. In the first part, A part, you have to draw the diagram to represent the situation. So here you see carefully, the ground speed is 518 miles per hour, the air speed is 480 miles per hour, and in between they have, if you see, 3 degrees of angle difference, because the direction here is given to be this and this. So 82 minus 79 is going to give you 3 degrees. So both are northeast direction. That's why both the vectors are in the northeast direction in the diagram. Then find the speed and direction of the wind. So you use the concept of linear combination of unit vectors to get your answer for B and C. Question 9 to 14 are very easy. We just have to use two formula. One is the distance formula, one is the midpoint formula. So let me write the formula here. So for the distance, we use the distance formula, which is the vector AB is equal to the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Remember, we are looking at 3D coordinates, that is x, y, z. So similarly, the midpoint formula will have three coordinates. So the midpoint is given by x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. So this is what we are going to be using. Now for all questions 9 to 14, same formula is going to work. So I'm going to just be solving two parts for you. The parts that we will be solving would be the first one and question 9, and let's take one more, question 12. So let's solve it in the next slide. Okay, let's solve answer 9. First we are using the distance formula. So remember, this is x1 y1 z1, this is x2 y2 z2. Just to avoid the confusion, we will write the values. And for distance formula, we'll take the square root of the squares, difference of squares. So this is the formula. So let's plug in the values. X2 is 1, x1 is minus 4, then y2 is 0, y1 is 10, then this is 9 minus 4 square. So what is this value? 1 plus this 5 square plus minus 10 square plus 5 square. So this is 25 plus 100 plus 25. So it is square root of 150. Now if you calculate the value approximately, it will come out to be 5 square root of 6, which is about 12.2 units. So this is the distance, this is the length of AB. Okay, we have got one part. Now we have to do the middle point or the midpoint. So we are going to use the midpoint formula. So the midpoint formula, the midpoint will be x, y, z, m, where x is x1 plus x2 by 2, y is y1 plus y2 by 2. So it's like in the middle, it's like the average. So let's calculate. So how much is this? Minus 4 plus 1 by 2. This is 10 plus 0 by 2, and this is 4 plus 9 by 2. So this is minus 3 by 2. This is 5, and this is 13 by 2. So what is the midpoint? The midpoint is xyz, which is minus 3 by 2, 5, 13 by 2. So if you look at the final answer for the length is this, the final answer for the midpoint is this, minus 3 by 2, 5, 13 by 2. So that's how you solve. Similarly, all of the parts can be solved using the same method and the same formula. So learn the distance and the midpoint formula. For the remaining questions, I have provided here the solution. So we have already seen question 9 and we have got the correct answers. I want you to similarly use the distance and the midpoint formula, and the answer for question 10, 11, 12, 13 and 14 are given here. So just the same method but different calculation and different numbers are there. I'm sure you'll all be able to solve it correctly now. So for question 62 and 64, the sample answer is given here. You just have to explain, if U and V are parallel in space, then how many vectors are perpendicular to both. So there are going to be infinitely many vectors that are perpendicular to a pair of parallel vectors, and this is coming because if two vectors are parallel, then they are coplanar. The coplanar means they are going to lie in the same plane. Also, due to the perpendicular transversal theorem, if a vector is perpendicular to one of the two parallel vectors, then it is perpendicular to the other also. So since a vector can have infinitely many perpendicular vectors, so there are going to be infinitely many vectors that are perpendicular to a pair of parallel vectors. Question 63 we have done. We've got the answer 2. For question 64, the definition of cross product A cross B is the vector perpendicular to the plane that contains both A and B. To have a vector that is perpendicular to the two-dimensional plane, a third direction is needed. That's why cross product is not defined for vectors in two-dimensional space, because in two-dimensional space there are only two axes like x and y. For cross product we need the z axis also, so that the perpendicular to the plane A and B vector, that one is defined. So I hope you know this is x, this is y, and this is z. So the z vector is the one which is perpendicular to both x and y, and therefore it defines the cross product. Let's calculate the cross product u cross v, which is calculated using the determinant I, j, k, the unit vectors, and then vector u 4, 6, c, and then vector v -3, -2, and 5. So let's calculate and open and expand this determinant. So it will be equal to I times, so you remove this row, remove this column, 6 -2, c, and 5, minus j, remove this row, remove this column, 4 -3, 6 -2, plus k, remove this row, remove this column, so 4 -3, 6 -2, absolute value, equal to I times 6 multiplied with 5 plus 2c minus j times 20 plus 3c plus k times -8 plus 18. So I have applied diagonal rule. I hope you have not forgotten. So you first calculate the primary diagonal, 6 multiplied with 5, that's 30, minus of this. So there is already a minus sign here in -2, so minus minus becomes plus. So this is equal to I times 30 plus 2c minus j times 20 plus 3c plus k times 10, and this is equal to the u cross v is already given. How much? 34i minus 26j plus 10k. So now compare the coefficients. What is the coefficient of I? This. What is the coefficient of I? This. So 30 plus 2c is equal to 34. The coefficient of j with the coefficient of j. So 20 plus 3c is equal to 20. So now let's solve it. 2c is equal to, I take the 30 to the other side and I take the 20 to the other side. So 34 minus 30, which is 4. So 2c is equal to 4 implies c is 2. And then 3c is equal to 26 minus 20, which is 6. So c is equal to, so you have got the value of c as, this is how you calculate the question. Okay, the last answer for the video is to determine if two vectors are parallel or perpendicular, you can use the formula for the angle between the two vectors. So how do you calculate angle between the two vectors? Cos of theta is equal to u dot v over magnitude of u multiplied with magnitude of v. So we use the dot product. So if to determine if two vectors are perpendicular, you can find the dot product of the vector. If the dot product is 0, see, if this dot product is 0 means cos of theta is 0. That means theta is pi by 2 or theta is 90. So it will become perpendicular vectors. Okay, this is the concept. And you can also use, if the angle measures 0 or 180, they are parallel. If the angle measure 90, they are perpendicular. So this is the concept of angle between two vectors. So the angle between the two vectors u and v can be calculated with the dot product using this formula. If it comes out to be 0 or it is 180, you know they are perpendicular vectors, and if you know that the angle is measuring 0 or 180, and you calculate cos of that value, it will come out to be 1, so you know they are parallel. So whether it is parallel or perpendicular vector, you can easily find using the dot product and this formula. That brings us to the end of today's session. I hope you found the video useful and you got some clarity about the knowledge of vectors. Here we have solved selected questions. So I hope they have been beneficial for you. Until then, this is Ms. Ruchika signing off from today's session and wishing all my grade 11 elite students best of luck for their coming exams. Bye-bye.